we're rather pleased with these shots. If you think you're looking, perhaps through a telescope, at the moon going through its phases, then we did fool you. Because what you were actually looking at was this model moon as viewed from the camera in our model Earth. And the moon was illuminated by sunlight coming in this direction from our model sun, a lamp, which is over there. And to get the lunar phases, we were moving the moon all the way around the Earth. Now, a word of caution here, because although we've got the size of the moon in the right proportion to the size of the Earth, we've got the distance between the Earth and the moon completely wrong. In fact, on this sort of scale, the moon ought to be 10 times further away. Nevertheless, the model was sufficiently good for us to be able to produce fairly convincing lunar phases. Now, as I was saying, you were looking at the phases from this camera on our model Earth. So what you were seeing is more or less what you'd see from the real Earth, the moon going through its various phases, apparently changing shape. But you know from our intellectual model of the Earth-Moon system, that's not the case. You know that the moon and the Earth are a fixed shape, they're both spheres. It's just that the moon goes round the Earth. So this apparent change of shape must be some sort of illusion effect when you look at it from the Earth. To see what's really going on, you really need to, so to speak, get outside the system and look in on it. So let's go right back through that sequence again, take the moon over the other side of the Earth, and see how it looks from a vantage point out there. Here's our starting position, and this is the moon's orbit. Now, sunlight comes into the system here, and the angle between the sun, the Earth, and the moon is about 20 degrees. As seen from the Earth, the moon appears to be a crescent. Move the moon round a little bit, and the crescent increases. When the moon's position is such that the angle between the sun and the moon is 90 degrees, a right angle, then we see a half moon from the Earth. Move the moon a bit further round, and we see the gibbous moon. The next phase should be almost full moon, with the sun, the Earth, and the moon almost in line. But instead, we get a partial eclipse. And at the exact full moon position, we get a total eclipse. The Earth completely blocks out the sunlight. And that will happen every month. Every time the moon gets behind the sun and the Earth, instead of getting a full moon, we'll get a total lunar eclipse. Now, we don't see eclipses every month, so obviously the model is wrong. But it doesn't mean we have to throw the model out completely. What we do is we modify it slightly. If I turn down the light, I can show you how. I simply raise the moon up so it comes into the sunlight. And now you can see that we will get a full moon. The only difference is that the moon's orbit must be inclined to the Earth. It's no longer in the same plane as the sun and the Earth. So the thing to do now is go back and have a look at it from outside the system with this orbit inclined. Of course, the angle here is greatly exaggerated because the moon in our model was too close. But we have got round that difficulty of an eclipse every month. The moon now misses the Earth's shadow altogether. But we've got another problem. How do we ever manage to see eclipses? Well, you've got to remember that the Earth and the moon also rotate about the sun. And in this sort of position, we can get an eclipse, though they're now much rarer than once a month. Well, we seem to be doing pretty well so far by having this double-edged approach of looking at the things from the earthbound observer's viewpoint and from the viewpoint of an observer outside the system. We seem to be showing that our observations and our model are consistent with each other. In fact, we've explained the lunar phases and the eclipses of the moon in terms of the moon orbiting the Earth and the Earth orbiting the sun. So it seems reasonable to carry on this double viewpoint approach to see if we can't explain some of those more peculiar phenomena that we see when we look out at the planet.